today we're going to be doing the week 4 AMS chemistry quiz. Now in the quiz you might see that I'm going straight up to the answers for a lot of questions. It's primarily because I was too tired to solve, so I just put some questions that I didn't want to think about, the random answers, and read their answers. But anyways, yeah, so for this quiz I'm only gonna be doing the brand new questions, because when I'm doing all the questions the videos are coming out very long, over most of the questions being things we've already taken for 2 weeks in a row. The question I'm gonna be not doing about 14 questions, but they're very basic questions that we've done a million times. Now let me start. Now, first, ionization energy of an oxygen atom is less than that of a nitrogen atom. Ionization energy, what is it? It is the energy required to remove an electron from each gaseous atom or ion in a mole of atoms or ions, which means that it's the amount of energy you need to remove an electron from any atom or ion in the gaseous state for a mole of them. Now we need to know a few things. That factors that affect the ionization energy are the number of shells, the atomic size. If it increases, ionization energy decreases. When we're going down a group, shielding effect, if it increases, ionization energy decreases. Nuclear charge, when it increases, i.e. increases, and that happens across a period. Now, what's it called? So we need to know here, these two, 8 and 7, they're in the same period, so across a period. Okay, so first let me draw both of their what's this called, the orbitals. 1s2, 2s2, 2p4. No, this is 4. Yeah, 2p4. And now for nitrogen, same thing almost. And just like that though. Now, the outermost electrons in a nitrogen atom is subjected to less repulsion than an oxygen atom. Yes, why? Because here you have 2 electrons sitting in the same house. Electrons don't like each other, so they repel each other. Since they repel each other, these two have repulsion between them. But here, each one is in its own room. They have nothing to repel. Since they have nothing to repel, they need more energy to take away one, because the one is happy in its house. It's not living with another electron that it wants to repel away. Whereas here in oxygen, it's more willing to give away an electron because 2 of them are sitting in the same degenerate orbital. When you have 2 in the same degenerate orbital, they're repelling each other. So it's gonna have a less ionization energy because it wants to get rid of the electron, so it needs less energy to get rid of it. So here it's undergoing less repulsion than in oxygen, of course. The double occupied 2p orbital increases the nuclear attractions? No. It's repelling each other, so it's not attractions, no. The electrons in the double occupied 2p orbital in oxygen are subjected to extra repulsion, of course. Shielding effect in oxygen makes it easier to remove the outermost electron. They have the same shielding effect. They both have the same number of orbitals, so this has nothing to do with it. Extra repulsion by the nucleus in oxygen makes it easier to remove the outermost electron. The repulsion isn't in the nucleus, so definitely no. Now, you need to take note, when we're going across a period, if it comes in written and this question comes in written, this is what you write. Across a period, they are in the same energy level. So therefore, they have the same number of core electrons. Therefore, they have the same shielding effect. However, nuclear charge increases, therefore, valence electrons are more attracted to the nucleus, therefore more energy is needed to remove valence electrons, therefore ionization energy increases. So the more you go across a period, the higher the ionization energy. Moving on to our next question, which I'm assuming is down a group. Yes, as we go down a group. Now, as we go down a group, the number of orbitals or shells increases. Therefore, the number of core electrons increases. Therefore, shielding effect will increase. So therefore, valence electrons are farther away from the nucleus. Therefore, valence electrons are less attracted to the nucleus. Therefore, less energy is needed to remove the electrons. Therefore, ionization energy will decrease. Why will it decrease? It is because when we go down a group, the number of electrons significantly increases and the number of shells increases. When you have more shells, they get more and more away from the nucleus. If this is your nucleus, of course it's gonna lose an electron from here way more easier than here, since it's way further away. So the average distance between the nucleus and the outermost electrons increases? Yes. Nuclear charge decreases? No. Now the shielding effect and the effect increases, leading to weaker attractions. Of course, nuclear attractions applied on the outermost electrons are weakened by the valence shells. They're weak, but they're not weakened by valence shells, so no. The nuclear repulsions are strengthened by the protons? How? Definitely not. Here again, it's going across a row, so the distance between the nucleus and the outermost are similar because they have the same shielding effect. Now the attraction between the outermost and electrons and nucleus increases. Of course it increases because when you go across a period, when you remove valence electrons, they're more attracted to the nucleus since they have a higher nuclear charge. So you need more energy to remove them. Shielding effect does not decrease, it stays the same. Nuclear attractions are weakened by extra electrons? Definitely not. And the nuclear repulsions are strengthened by the core electrons. The repulsions are strengthened by the core electrons? No. It's only valence electrons that have anything to do with repulsion. Moving on. For this question, you need to memorize the formula E equals K Q1 Q2. You never use the formula, but you need to know it. So E is directly proportional to the charges and inversely proportional to the radius. Moving on. So here are your first three elements between 1 and 20. Your first 20 elements, my bad. So B, F, and I are noble gases. You could just circle them and then count. B is the second one, which is helium. This is neon, and this is 18th, which is argon. All three of these are noble gases, so yes. E and H have half-filled p orbitals. E and H. E and H. E is basically 1, 2, 3, 4, 5, 6, 7 nitrogen, and this is gonna be phosphorus, I think. Yes. So when you look at your periodic table, they're in the same group. If they're in the same group, they both end with the same orbital, and if one is half filled, the other is half filled. But we should draw it always in the exam to be sure. So I'm drawing nitrogen right now. 4, and now you need 3 more. So we end on a half-filled p orbital. Now for phosphorus, it's 15. So it's up, down, up, down, up, down. Then another 2. So there we have 12 so far, and now again up, up, up. They both ended on the exact same thing. So yes, they do both have half-filled p orbitals. C and F have the same shielding effect. C and F. Wait, this is... yeah. C and F have the same shielding effect. So C is here and F is here. C is third, which is lithium, yes. And F is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is neon. Yeah. Do they have the same shielding effect? Yes, they do. Why? Because lithium and neon are both elements of period 2. They're both in the same period, so they have the same shielding effect. C and G belong to the same period. Let's see. C and G. C is the third, which is lithium. G is... If F is... Yeah, wait. 4, 5, 6, 7, 8, 9, 10, 11. The 11th one is Na. They belong to the same group if you look at your periodic table, but not the same period. So it's only 1, 2, and 3. Moving on. Now, why does the ionization energy increase as we go across a period? We said nuclear charge will increase and the electrons remain at the almost the same distance because we don't have any different shielding effect. Electrons are not farther away from the nucleus as we go across a period. They have the same, they end at the same orbital. The shielding effect increases? No, it stays the same. Again, same N. Number of energy level? No, same N, which is energy levels. Spin pair repulsion decreases? No, it has nothing to do with it. Moving on. Okay, so again, here, except it's down a group. Last question I did open answer, right? Yeah. My bad. So down a group. Down a group, does the nuclear charge increase while the electrons remains at the same average distance? No, we said that's across a period. Now, the outer electrons are farther away from the nucleus, yes, because we have more energy levels, so it increases the distance or the shells from the electrons. The shielding effect increases, of course. Number of energy levels increases, of course. Spin pair repulsion decreases? No, it increases actually. Now, so the addition of the now, first and second electron affinity of oxygen. Always know one thing. Whenever you have your first electron affinity is different than ionization energy, by the way. Electron affinity is, what's it called? It's a different rule, but let me get you the exact rule. Yeah. Electron affinity is the energy change associated with the addition of an electron to a gaseous atom. So there it was removing, here it's adding. So whenever, just know this one rule. First, so E-A-1 is exo, and the rest, E-A-2 and onward, is endo. So these are the only two, because it says first releases, which means exo, second requires, which means endo. The rest here are the opposites, so it is only 1 and 2. Moving on. Now, lithium with water. So we know that lithium plus H2O. Li is Li plus. OH is OH minus. So they're already LiOH. We don't need to crisscross anything. And then you're gonna be left with, since we're using one O and one H, we're gonna be left with H. But we can't just have H as a gas, so we need H2. So you need to multiply this by 2 and multiply this by 2 and multiply this by 2 to balance out the entire equation. We should all know how to balance by now. And always know, whenever you have a metal reacting with water, you're gonna have hydrogen and the salt. Or sorry, hydroxide and the hydrogen. What affects atomic radii, which means the distance between the nucleus and the valence shell? nuclear charge, of course, the number of energy shells, of course, and the shielding effect. Whenever number of energy shells increases, shielding effect increases, so they're like proportional, kind of. Repulsion has nothing to do with it. Valence electrons has absolutely nothing to do with it. So, here. Yeah. Knowing that sodium and chloride belong to period 3, how does the ionic radius and the atomic radius increase? Now, the ionic radius is basically when it's an ion. Now, we know that cations are positive, right? So, Na plus Cl minus. Now, look, when we have Na plus, it means we have one extra proton. So when you have one extra proton, you have more protons to pull in more electrons. So you have a greater positive than negative. But in Cl minus, you have a greater negative than positive. So if you have a greater negative than positive, it's gonna be bigger, because the negative is the electron shell. If it doesn't have anything pulling it closer to the nucleus, aka the protons, it doesn't have anything holding it from being big. So Cl is bigger because Na, the protons are pulling in the electron shells. Now atomic radius, look, so now for the atomic radius, why is sodium's bigger than chlorine? It's because as we go across the, nuclear charge, it increases, and when nuclear charge increases, the atomic radius decreases. Yeah, anyway, so moving on. Oh yeah, I forgot to. Now, why is it easier to remove an electron from 2p in an O2 minus than to remove 1 from 2p of an Ne atom? Now, it has a lower nuclear charge. Is the only correct answer. It doesn't have a higher energy level because they have the same energy level, Ne and O, because they're in the same period. Now, when it has a lower nuclear charge, because it's before Ne in the period, so it's easier to remove. It has a greater, if it has a higher nuclear charge, it has a higher ionization energy. Since it has a lower nuclear charge and a lower ionization energy, it's easier to remove from. Partially filled? No, because it's an ion, it fills its electrons to be like the noble gas, so they both have the same filled orbitals. So it's 2 only. Now here, this is very easy. How do you find the position in the periodic table? First of all, you look at the last number, the energy level, 4. So that's your period number. And then you count the electrons in that energy level. So in 4, you have 2 plus 5, which is 7. And that is your group. So D is your only correct answer. Moving on. What do elements in the same group have in common? They have the same chemical reactivity and number of valence electrons. They don't have the same mass number, they don't have the same energy levels, nor atomic number. Moving on. Okay, so now we need to let me draw a periodic table really quick. Very much artistic skills. Anyways, so this part of the orbit of the periodic table, we need to split it into 3 parts. This part is the S part, this is P, and this is D. The ones in the bottom are F, but we forget about them for now. So Fe is a transition metal, so it is in D. What do I mean by it is in D? It means that all the elements in this section end with something D, whatever. All the ones in this part end with S, and all the ones in this part end with a P orbital. Moving on. Okay, so I'm gonna skip from question 17 to 18. We're gonna go to question 19. Okay, so we're at question 19. Now, whenever you see this, you might feel scared. It's very easy. This is 1s2, this is 2s2, this is 2p6, this is 3s2, and then what comes next? It's 3p. Now, why is 3p not at 6? It's not, because it doesn't want to be. We know that this level is 1. Since this level is 1, it is 3p1. And that's your entire first part answered. There you go. Second part, what's element X? You just count the electron superscript. You're gonna get 13, which is aluminum. Now, element Y is to the right of element X. Therefore, it's 1s will have... it's to the right of element X on the periodic table. It's to the right. Okay. Whenever you go more to the right... Whenever you go more to the right on the periodic table, sorry, my mic lagged. So whenever you have an element to the right of another element on the periodic table, it's gonna have a higher binding energy. Why? It's gonna be here. Because I don't know, they didn't show us units. They didn't show us units on this, but here it's the highest units. Here it's the lowest. Based on the graphs that were in our examples, as I remember. Yeah. So it's gonna have a higher binding energy than element X. Moving on to... We're gonna again skip till question 25. Because everything in between we've taken before. If I'm not mistaken. Yeah, we did. For this question, it's just n squared. Okay, now we're at question 25. The first ionization energy of gallium is less than that of calcium. Why? Because now, wait, first we need to see where gallium and calcium are. So calcium is before gallium in the same row, it's in the same period. Okay, but calcium is before gallium. So if they're in the same period and one is before the other, that gallium is less penetrating towards the nucleus because it has what's it called? Because it has a higher nuclear charge, so that the valence electrons are more attracted to the nucleus, but they have equal shielding. By the 4p electrons, if you write it down, you're gonna find that they end with p. So it's gonna be 4p, and less nuclear attractions because... Sorry guys, I mixed up. The reason that the outermost electron is less penetrating, because they told us it's less in the question, it's subjected to more shielding by the 4s electrons. What does this mean? That means that, like, when you write it down, it's... Wait. 1s2, 2s2, 2p6, 3s2, 3p6, 4s. Wait, 3p6, we reached it. Still there, it's 18. 4s2. We're writing that of... Wait, so 2, 10, 12, 18, 20. Now 3d, 10, and 4p. One. Now it has more 4s, so it's more shielding because calcium stops at the 4s. Here in gallium, it moves on. It has 2 more energy levels. Or not 2 more energy levels, but it has 2 more. And it's less it has less nuclear attraction because the valence electrons are further away from the nucleus. Calcium, it's just the same as this till here. So 4s is your last thing. It isn't shielded. It is the shield. Moving on. Now our next question is gonna be question 20. No, it's fine. 26. 29 we won't do. Okay, so for this question it's very easy. It might look hard, but it's not. You look, where do you find a significant jump? Here you have a normal jump. Here you have a normal jump. Here jumped from 2000 till 11,000. That's a significant jump. By the way, how you're supposed to do this is you find the ratios. Like you do this, divide by this, find the ratio. This divide by this, find the ratio. This divide by this, find the ratio. And then the one with the biggest ratio, like here, this is gonna have the biggest ratio. So you're gonna stop here. It means it only goes to the third ionization energy, which means it has a charge of 3, since it's with oxygen, 3 plus. And that's it. Because we know that ionization energy is the one required to remove an electron, so it's going to be positive. So it's x2 because it's x3 plus O2 minus crisscross x2 O3. Moving on. Another mass spectrum. For this, 1s2, 2s2, 2p6, 3s2. Add them together, you're gonna get 12, which is magnesium. Outermost orbital is D. The strongest nuclear attraction is the one closest to the nucleus. And as I told you, look, here it has the highest binding energy and here it's the lowest. Moving on. Okay, so in this question, it's really easy. So listen, whenever you're given these, first of all, let us write how many protons and how many electrons they each have. So Ca has 20 protons and 18 electrons. Ca2 plus, by the way. K plus, it has 39 protons and no wait, what? Yeah, 39 protons and 38 electrons. My bad, 39 is its charge, I was confused. K is, sorry, half asleep, 19 protons and 18 electrons. And here we have Cl is 17 protons and 18 electrons. Now, what do we call things with the same number of electrons? We call them isoelectronic. Now, whenever you have isoelectronic atoms, the one that's the biggest is the one that is most negative, or the biggest negative charge. So whenever you have the most, all electrons the same, the one with the highest positive charge is the least. So 2 plus least, then plus, and the one with the highest negative charge is the most. So if you had, for example, N3 minus. N3 minus would be the biggest. But let's say you had noble gas. The noble gas will be perfectly in the middle. Moving on to the next question. We've done this before, moving on. This question we've done before, but it is just a bit new. So, electronic configuration of an atom. First, you write the exact, like the normal one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. Now, it's vanadium 2 plus. Whenever you want to write an ion, first of all, you write the atoms. Then you look for the highest energy level. In this case, the highest energy level is 4. If you had 4s and 4p, you take from 4p. If you have 4s and 3d, you take from 4s. You take from the highest energy level. But let's say you have 4s and 4p, you take from 4p. So here, you need to take 2 electrons, because it's 2 plus, from 4s2. When you take these away, it becomes 4s0. So you could just remove it. So you're left with this as your configuration. Moving on. This question we've done a million times. I'm gonna skip. Okay, so here it's just asking us what's the adding of an electron in a gaseous state. It's called electron affinity. Whenever you say addition, it's electron affinity. Removing is the ionization energy. Now sulfur, what's the electron affinity of sulfur as a normal sulfur, not the atom or the ion? Sulfur gas, it has to be gas, plus an electron is S minus. You're gonna say, but isn't sulfur S2 minus? Doesn't matter. Here it's addition or removing of 1 electron only, so it is fine. So S plus 1 electron is S minus. Moving on. Okay, so sodium is a metal, so it has a metallic bond. Fluorine is a molecular compound, so it has a simple molecular. Carbon is a giant molecular. Carbon and silicon and all group 4 are giant molecular structures. They're most likely only gonna give you silicon and carbon. Oxygen is simple molecular. Iron is a metal, so it is metallic. Moving on. Now for this question, you're gonna say, oh, but we didn't really know how to take these yet. Now look, whenever we have a periodic table, okay, that's the worst periodic table ever, but anyways, here let's say it's fluorine. It usually decreases electronegativity as we go like this. So listen, so whenever we have elements in this side, they're higher in electronegativity than this side. So already we know that selenium and oxygen, since they're both in group 6, are gonna be higher than than potassium and lithium that are both in group 1. Now, since we know oxygen is above selenium in the group, and we know already from, I don't know if you took it in class yet, oxygen is the 3rd most electronegative or 2nd most electronegative. So it's gonna be the most out of this list. Then selenium, because it's the next non-metal. Then it's gonna be lithium, because it's higher than potassium up on the list and in the group, and then it's gonna be potassium. Moving on. We're gonna move, Here it's very easy. We have Na plus oxygen. Na is +1, oxygen is 2 minus, crisscross NaO2. And Mg is 2 plus, MgO. Al2O3, crisscross Al2O3. Si, it's gonna be Si2O4, but you can simplify and make this 2. Phosphorus is an exception. Please, please, please memorize it. It's either P4O10 or P2O5. Memorize it. Now with chloride, it's NaCl. Now here it's MgCl2, AlCl3, SiCl4. You could just do these normally, crisscross. And for phosphorus, it is Cl5. Memorize again. I think it's PCl5 or PCl3. Both work. Both are gonna give you correct. I'd rather you go with PCl3 because it's more logical, since it is in group 5 and it's 3 minus. Or 3, I forgot, 3 plus? No, it's 3 minus. Okay, so this question, it's a pain to do because the mark scheme it wants it in like this form. So our answers are correct. So aluminium reacts with oxygen to give 2Al2O3. This question is the exact same as the questions before it. It's just that they want you to do it and balance. Mg plus O2 gives you 2MgO. Here in phosphorus, like I told you, it's an exception. So please memorize this formula for phosphorus because it is different than the rest. The rest should all be very straightforward. And for this, you genuinely just need to understand or memorize the formulas. I can't really help with them. Now we're gonna skip till question. Oh yeah, we're done for the rest. The rest, it's all old material, as you can see. And yeah, I hope you understood everything. Now, for AS students, the AS video will most likely come out tomorrow. I'm recording this on Wednesday, by the way. I'm recording this on Tuesday. It most likely will come out tomorrow. And I am only doing the questions that were not shown up in this quiz. So that video is gonna be way shorter because I'm depending that you're gonna watch this video and only watch the new questions in that video. Now, have a great day. Bye.